We are literally standing on one of the 800-ton blocks in the western wall here at Baalbek. Just about from this angle, just below me are the 800-ton stones, and below them are the 400-ton stones. So it's amazing to actually be up here, like literally on the wall itself.
In 2024, researchers fed every known measurement, scan, and historical record from one of the most mysterious ancient sites on Earth into a pattern recognition AI, expecting confirmation of a story we've accepted for centuries. Instead, the results brought the room to a standstill. The tool marks didn't match any known civilization. The physics required to move the stones didn't add up. And the astronomical alignments pointed to a time thousands of years before Rome even existed. So if the Romans didn't build Baalbek, who did?
And there's no evidence the Romans did that. That's why it's often said that giants did it. There's also some traditions that say demons did it.
When the AI widened its analysis to other ancient sites around the world, the implications grew darker. It detected a shared engineering signature, a repeating pattern of knowledge spread across continents that should never have been in contact. Coincidence or evidence of something erased from history? The stones beneath Baalbek don't belong to Rome, and they don't belong to any civilization in the historical record. They point to a possibility historians have long resisted, an advanced culture that mastered engineering we still struggle to explain, and then vanished so completely we forgot it ever existed. Today, we step inside the investigation that's forcing a final, uncomfortable question. What else about our past have we been wrong about? The site that refused to fit Baalbek sits in the Bekaa Valley of Lebanon, a sprawling complex of temples and platforms that tourists photograph without understanding what they are looking at. For generations, the official story was simple and clean. Romans built it. End of discussion. The empire had the manpower, the engineering knowledge, and the ambition to construct massive monuments across their territory. Baalbek was just another example of Roman greatness, a temple complex dedicated to Jupiter that showcased the power of classical civilization. Historians repeated this explanation in textbooks and documentaries. Tour guides recited it to visitors. The case was closed, the mystery solved, the site understood. Except it was not. Beneath the Roman temples, beneath the columns and carved facades that every photograph captures, lies something far older and far more troubling. A foundation platform made of stones so massive that modern engineers struggle to explain how they got there. 3 blocks known as the Trilithon weigh approximately 800 tons each.
Each of these stones weigh in at a whopping 800 metric tons, which equates to nearly 900 imperial tons apiece.
They measure 64 feet long, 14 feet high, and 12 feet thick. These are not decorative elements or artistic flourishes. They are the base upon which everything else was built, and they do not match Roman engineering practices at all. The Romans left meticulous records of their construction projects. They documented techniques, celebrated achievements, and preserved knowledge for future generations. Yet nowhere in those archives does any reference exist to cutting, moving, or placing stones of this magnitude. The largest blocks Romans are known to have transported weighed around 300 tons, and those projects were considered extraordinary achievements worthy of special mention. The Trilithon stones weigh nearly 3 times that amount, and the Romans apparently said nothing about them. This silence troubled researchers for decades, but the standard response was always the same. The records must have been lost. The techniques must have been forgotten. The explanations must exist somewhere, even if we have not found them yet. That confidence began to crack when a new generation of investigators arrived at the site with technology their predecessors never had. They brought ground-penetrating radar, laser measurement systems, chemical analysis equipment, and something that would change everything. A pattern recognition AI designed for engineering forensics. The machine had been trained to identify microscopic signatures in stone and metal, to interpret structural data, and to compare findings against every known construction tradition in human history. It had already proven itself on Roman bridges, Mayan pyramids, and ancient Chinese foundations. The team trusted it because it did not speculate or theorize. It only analyzed data and reported what the numbers showed. When they pointed it at Baalbek, they expected confirmation of the familiar story. What they received instead was a systematic demolition of everything historians had claimed to understand. The tool marks that matched nothing. The investigation began with the simplest question. What tools cut these stones? Every civilization leaves signatures in the materials they work. Bronze chisels create different patterns than iron tools. Hand percussion leaves different marks than abrasive grinding. By studying the microscopic details of cut surfaces, researchers can usually identify the techniques and approximate the era of construction. The team collected thousands of close-up scans, hundreds of detailed photographs, and chemical readings from surfaces across the site. They uploaded everything to the AI and instructed it to compare the marks against its database of known ancient tooling traditions. The results came back negative across the board. The cuts did not match Roman iron chisels. They did not match Phoenician wedges. They did not match Assyrian picks or Egyptian copper tools or Neolithic stone implements. The AI tested every tradition in its library and found no correlation strong enough to identify a source. But the system did not stop at elimination. It also described what it saw, and that description raised questions nobody expected. The surfaces were unusually smooth. The channels followed precise paths with consistent depth from beginning to end. There was no evidence of hammer pitting, no signs of chisel vibration, no irregular impacts that should appear when humans strike stone with metal tools. The cuts looked controlled in a way that hand tools could not achieve. The AI flagged several similarities to industrial cutting techniques that use flowing water mixed with abrasive particles. These methods guide a steady stream of water along the cut line, while suspended minerals do the actual grinding. The result is a smooth, consistent channel exactly like what the scans showed. Chemical analysis added another layer of impossibility. The AI detected quartz sand and small fragments of corundum on the cut surfaces. Both minerals are harder than limestone and function as powerful abrasives when suspended in water. Neither mineral occurs naturally at the site. Someone brought them there deliberately, which suggested organized planning and material sourcing that the standard historical narrative never mentioned. The implications were unsettling. If the builders used water-based abrasive cutting, they possessed knowledge that did not appear anywhere else in the ancient Levant. The Romans never used such methods. Neither did any other civilization known to have worked in the region. The quarry floor revealed even more. The AI identified evidence of freeze-and-thaw extraction, a technique where workers carve narrow trenches around a block, fill them with water, and allow winter temperatures to freeze it. As ice expands, it exerts tremendous pressure against the stone, eventually separating the block from the bedrock. The system detected patterned vertical cracking and fracture lines consistent with this method. It also found shallow channels in the quarry floor that appeared designed to guide water into position. Similar techniques existed in prehistoric Scandinavia and early Chinese quarries, but none of those examples operated at anything close to the scale seen at Baalbek. The cutting system did not belong to any known culture in the region. It was scientific, controlled, and carefully planned. And if the cutting was this advanced, then moving the stones would present an even greater mystery: the physics that broke every theory. The team had expected the tool mark analysis to be the difficult part. They assumed that once they understood how the stones were cut, the transport question would resolve itself through familiar explanations. Wooden rollers, rope teams, sledges on wetted ground,
which is by far the most commonly accepted theory, which involves the use of capstans and ropes to slowly pull and drag the stone blocks.
brute force applied by thousands of coordinated workers. These methods had explained other megalithic sites around the world. Surely they would explain Baalbek. The AI was given every variable the team could measure: the exact weight of each block, the tensile strength of ancient rope materials, the compression limits of wooden rollers, the friction coefficients of different soil types, the slope of the terrain between quarry and platform, weather conditions estimated from historical climate data. The system was instructed to assume perfect coordination under ideal conditions. The team wanted to be generous. They wanted to know if any traditional method could work even in the best possible scenario. The AI ran more than 10,000 simulations. It adjusted roller spacing, changed rope configurations, tested different wood types, shifted path angles, examined sledges with and without lubrication. It even modeled shallow incline adjustments to see if the terrain itself could support the load. Every simulation failed. Wooden rollers collapsed almost immediately under weights approaching 800 tons. The friction generated so much heat that the wood charred and splintered within inches of movement. Even with constant roller replacement, the system could not sustain transport. Rope-based hauling was equally impossible. To generate enough pulling force, the ropes would need to be wider than a human torso. The total weight of rope required would exceed the weight of the workforce pulling it. No known ancient rope-making tradition produced materials strong enough to survive the tension. Workforce estimates created the most disturbing numbers. To move a single trilithon stone, more than 30,000 people would need to push or pull simultaneously. There was no physical space around the blocks to position that many bodies. Even if space existed, coordinating 30,000 people to apply force in perfect synchronization would be logistically impossible. The AI labeled the scenario as unrealistic in any configuration. Sledge-based transport offered no relief. In nearly every simulation, the stones sank into the soil under their own weight. Wetting the ground to reduce friction only increased suction and made the problem worse. The team watched simulation after simulation end in failure. According to researchers present during the review, frustration turned to disbelief as every traditional explanation collapsed. With all known methods eliminated, the AI proposed an alternative model. It suggested that the builders created extended transport routes with artificially smoothed surfaces, reshaped terrain along the path, used triple-layered roller systems with engineered weight distribution platforms, and applied coordinated mechanical advantage at multiple points. This level of infrastructure planning would require surveying knowledge, material science, and project management capabilities that no known ancient culture in the region possessed. The transport was not a matter of brute strength. It was a matter of advanced engineering design, and the question of who possessed such knowledge remained completely unanswered. The sky alignment that erased Rome. After the transport analysis, the team expected the investigation to wind down. They had already gathered enough anomalies to challenge the standard narrative, but the AI had one more data set to examine, and what it found would push the timeline back by thousands of years. The system was given laser measurements of the platform orientation, precise sight lines, horizon profiles, and solar position data. It ran these numbers against sky models that simulated celestial positions across 12,000 years of history. The program accounted for axial precession, the slow wobble in Earth's rotation that shifts the apparent position of the sun and stars by small amounts each century. Precession completes a full cycle in approximately 26,000 years. For astronomical alignments, this drift is critical. A structure oriented to a specific sunrise position today would have faced a different point on the horizon 5,000 years ago. The AI overlaid the platform alignment against solstice and equinox positions across different eras. It checked where the sun would have risen at the exact azimuth the platform points toward, century by century, millennium by millennium. The results stunned everyone in the room. The platform matched the summer solstice sunrise, but not for the Roman period. The geometric fit was perfect for an era roughly 7,000 to 9,000 years before the Common Era. This was not Roman. This was not even Bronze Age. This was deep prehistory, an era when historians believed the region was populated by simple agricultural communities with no capacity for monumental construction. The implications were severe. If the platform was oriented to a prehistoric solstice, then whoever designed it understood solar geometry well enough to predict sunrise positions across long time spans. They possessed knowledge of horizon modeling, celestial cycles, and architectural planning that should not have existed for thousands of years after their apparent construction date. The team compared this finding to other deep time sites. Göbekli Tepe in Turkey shows astronomical awareness dating back 11,000 years. Nabta Playa in Egypt contains stone arrangements aligned to ancient solstices. The Maltese temples face astronomical events from eras long before recorded civilization. Baalbek now joined this pattern, suggesting that scattered groups in prehistory observed the sky with precision and built monuments to mark their observations. The Romans did not design this platform. They inherited it. They built their temples on top of something far older, something that pointed to a sky they never studied and an era they never knew existed. The accepted history of Baalbek had not just been questioned, it had been erased. The ground that knew too much. The alignment data forced the team to look downward again with fresh eyes. If the platform belonged to a prehistoric astronomical program, then the ground beneath it might hold additional evidence. The AI was paired with new ground-penetrating radar surveys and detailed soil analysis. Together, they produced a three-dimensional map of the bedrock beneath the Trilithon stones. What emerged from that map did not look random at all. The radar revealed zones of strong bedrock, zones of weakness, and hidden fractures that ran through the foundation like fault lines. The AI overlaid the exact footprint of each 800-ton stone onto this map, and the correlation was immediate and precise. Every single massive block sat directly on the strongest patch of bedrock available. In several cases, shifting a stone by only 4 or 5 feet would have placed it over a weak zone. That tiny change would have caused uneven settling and likely structural failure within centuries. The builders had not just placed heavy stones on the ground. They had surveyed the subsurface with enough precision to identify the strongest positions down to the foot. The joints between stones revealed even more sophisticated thinking. Laser scans of the mating surfaces showed shapes designed to self-tighten as weight pressed down from above. The stones were cut so that under load, they locked together more firmly. This effect resembles techniques used in modern earthquake-resistant design. The geometry distributes stress dynamically, reducing the chance of failure when the ground shifts. Japanese pagodas use similar principles, but those structures appeared much later in history. Roman architecture relied on arches and relieving chambers. Egyptian builders used sheer bulk to resist movement. None of those traditions employed bedrock selection to the inch or joints that tightened under pressure. The engineering at Baalbek combined subsurface surveying with stress-aware construction in ways that match modern civil engineering more than ancient tradition. The builders understood how to read bedrock strength, avoid hidden fractures, and shape joints to manage dynamic load. This implied organized teams of specialists who combined geological knowledge with construction planning. The level of coordination required does not match anything in the historical record for early societies in the Levant. The ground beneath Baalbek had not been randomly chosen. It had been deliberately selected by people who understood forces that would not be formally described for thousands of years. The stones that exceed all records. With the bedrock analysis complete, the scale of the stones themselves became impossible to ignore. The Trilithon blocks weigh approximately 800 tons each. Those numbers alone exceed the largest stones Romans are documented to have moved. But the quarry held something even more extreme. A block called the Stone of the Pregnant Woman weighs roughly 1,000 tons. It was quarried and shaped almost completely, but never moved from its cutting position. And in 2014, surveyors identified another block nearby that appears to weigh approximately 1,650 tons. This stone also lies where it was cut, abandoned in place as if the builders simply walked away. The AI ran calculations with brutal precision. It compared lifting and hauling requirements against every technology known to have existed in the ancient world. For cranes, no rigging system from any era could safely lift masses of this magnitude. For roads, the infrastructure required to support transport would constitute major engineering projects in their own right. For ropes, the tensile demands exceeded all known ancient materials. For manpower, the workforce densities required were logistical impossibilities given available space and coordination limits. Modern engineers were brought in to challenge the findings. They attempted to design transport schemes using contemporary equipment, multi-axle transporters, staged lifts, and heavy cranes. Even with modern tools, moving a 1,600-ton block would be a major undertaking requiring months of planning and specialized infrastructure. The conclusion was stark. Either an unknown technology existed at the time of construction, or the builders possessed logistics and engineering capabilities far beyond anything in the historical record. The standard picture of gradual technological progress collapsed at Baalbek. The stones demanded explanations that existing history could not provide. The network that should not exist. The final stage of the investigation began as a routine comparison, almost an afterthought. The team had already gathered enough anomalies to challenge decades of accepted history. The tool marks pointed to unknown methods. The transport physics defied explanation. The astronomical alignments erased the Roman timeline entirely. The geological engineering revealed knowledge that should not have existed. By any reasonable measure, the investigation had accomplished its purpose. But the AI had one more task to complete, and what it found in those final hours would transform Baalbek from an isolated mystery into evidence of something far more disturbing. The system was instructed to compare Baalbek's engineering signatures against other ancient sites around the world. The team expected minor similarities at best, perhaps a few coincidental matches that could be explained by independent development or shared environmental pressures. Ancient builders everywhere faced similar problems. Heavy stones needed to be moved, structures needed to stand. It would not be surprising if different cultures arrived at similar solutions through trial and error. The researchers prepared themselves for a quiet conclusion, a final report that would confirm Baalbek as unique and leave the broader questions for future generations to answer. Instead, the AI returned results that froze the room into absolute silence. The system did not find isolated matches. It found entire clusters of shared engineering patterns spread across sites that should have had no contact whatsoever in deep prehistory. The distances involved spanned thousands of miles. The timelines stretched back beyond the reach of any documented civilization, and yet the signatures repeated with consistency that could not be dismissed as coincidence. The AI began with tool marks. It compared Baalbek's microscopic cutting channels to samples collected from Göbekli Tepe in Turkey, Nabta Playa in the Egyptian desert, Ain Ghazal in Jordan, early Jericho, the megalithic temples of Malta, dolmens scattered across the Caucasus Mountains, and pre-dynastic foundation stones in Egypt. The channel angles matched, the depth signatures aligned. The smooth precision that had seemed impossible at Baalbek appeared again and again at sites separated by continents and millennia. The team initially suspected an error in the data. They rechecked the files twice, verified the source measurements, and ran the comparison again. The matches remained. The astronomical alignments created another layer of connection. The AI tested each site against prehistoric sky models, calculating where the sun and stars would have risen at different points in the distant past. Multiple sites pointed to solstice or horizon events from similar eras that predated written civilization by thousands of years. These alignments did not match Roman or Egyptian or Mesopotamian astronomical traditions. They belonged to a time before those civilizations existed, when historians believe humanity lived in scattered agricultural villages with no capacity for monumental construction or sophisticated celestial observation. Yet the numbers showed otherwise. Geological placement strategies revealed the same disturbing pattern. The AI had identified how Baalbek's builders placed massive stones on the strongest bedrock zones while avoiding hidden fractures by margins of just a few feet. When the system examined other sites, it found identical behavior. Strong bedrock ridges were selected. Weak zones were avoided. The precision repeated across locations that should have developed independently. Some researchers argued this could be coincidence, that any intelligent builder would seek stable ground. Others pointed out that the consistency was too exact, that avoiding fractures by such small margins required subsurface knowledge that simple observation could not provide. The quarry data delivered the final shock. Baalbek's freeze and thaw extraction signatures, the patterned vertical cracking that indicated controlled ice expansion, appeared at sites in the Caucasus and matched fracture lines documented at prehistoric quarries across multiple regions. This extraction method requires understanding of how temperature changes affect stone at a molecular level. It requires planning across seasons and coordination across work teams. Its presence at multiple distant sites suggested shared technical knowledge rather than independent discovery. When the AI integrated every data set, tool marks, alignments, geological choices, extraction methods, and measurement ratios, one conclusion emerged from the analysis. These sites may share a single engineering tradition. The pattern suggested knowledge transfer across regions, shared methodologies passed between distant groups, and consistent approaches to solving architectural problems that appeared nowhere in the historical record. This would imply communication or cultural continuity across continents long before any established civilization emerged. Baalbek was not an isolated anomaly. It appeared to be one node in a prehistoric engineering network that spanned the ancient world. If such a network existed, then an entire civilization or connected group of cultures rose to remarkable technical sophistication, built monuments we still struggle to explain, and then vanished so completely that we forgot they ever existed. Their knowledge of geology, astronomy, surveying, and stone engineering disappeared entirely, surviving only in the silent stones they left behind for us to puzzle over thousands of years later. Think about what this really implies. Somewhere deep in prehistory, knowledge rose to heights we're only beginning to recognize, and then vanished without a trace. Baalbek wasn't hidden. It stood in plain sight while we told ourselves a story that felt safe, orderly, complete. The data has now stripped that comfort away. If an advanced understanding of the world could disappear once, erased so thoroughly that even its builders were forgotten, then our own certainty about progress becomes fragile. This isn't just a mystery carved in stone. It's a warning written across time. And as new sites are scanned and new patterns emerge, one question lingers in the silence left behind. If history forgot them, what makes us so sure it won't one day forget us too? The stones are still waiting, and they have more secrets to tell. Have more secrets to tell. Have more secrets to tell. Have more secrets to